Welcome students. In the previous class we have discussed about how to interface an discrete LED with our microcontroller 8051. Now in this session let's discuss how to interface 7 segment display modules with our 8051 microcontroller. So before going to details of the types interfacing of 7 segment displays, let me discuss about the two different types of 7 segment LED modules that is available in our market. The first one is the common anode type, in which we have 7 segments, that is segment A, B, C, D, E, F and G, followed by the display point. Okay. So this is basically the in order to implement a digit. Okay, if I need to implement 0 1 2 3 etc, and even I can go for implementing A B C D. Okay, so in those cases I'll be I'll be just focusing on this particular 7 segments, that is A to G. And if I need a precision I need to implement a display of which displays 1.22 volt using this 7 segment 1.22. In that case I can go for that decimal point representation with this 8 segment, that is DP. Okay, so in normal cases we discuss the operation of this particular uh, component where we are more focused on how to turn on and off each of these segments corresponding to a digit. So we call the component as 7 segment. Okay, so actually the internal implementation of each of these segments is equivalent to an LED. So here we have 7 LEDs, an LED corresponding to segment A, another LED corresponding to segment B, then we have LED for C, D, E, F and G. Okay, that is for 7 segments we have 7 separate LEDs. Okay, so when we go for interfacing, as we have seen in the case of an LED interface, either we can connect the anode terminal of these LEDs to the VCC by default. Okay, so in that case we go for the low side control scheme, and if we have the connect the cathodes of the LED to the ground by default, and we are controlling the turn on and off with respect to the voltage that is applied to the anode terminal of LED, then in that case we go for the high side control scheme. Okay, so here how they are implementing is that the anode terminals of all, if all the anode terminals of the 7 segments are connected to the VCC as a single point, then we call that particular segment as a common anode scheme. And in order to turn on each of the LED we need to provide a logic 0 to the corresponding segment pin. Okay, and if the cathode terminals of all the 7 segments, okay, of all the segments are connected together and a single pin is there, and to enable this particular LED, this common pin should be connected to the ground, that is common cathode. Okay, that will be grounded, so that in order to turn on and turn off each of the segments we need to supply a logic 1 to the corresponding segment pin. Okay, so that particular configuration is known as common cathode. So based on this particular configuration, if I go for a common anode scheme, in order to on a particular turn on a particular segment, I need to supply a logic 0, and for common cathode I need to supply logic 1 to that particular pin. So if I need to display digit 0, if we go for back, if I need to display 0 in this, except this segment and this display. Okay, since I need to consider all the pins, I am considering except this segment, that is a G, A, B, C, D, E, F, G. Okay, except G and DP, all other segments should be connected to ground, so that I will be getting a value 0 displayed. Okay, similarly if I need to display 1, I need to turn on this and this alone, that is B and C alone, all other should be turned off. Okay, so based on that, if I write the table for G, as I told, I need to turn off G and H alone, all others should be turned on, so I am writing 0. And if I configure the 4 bits together, so A B C D together, that is 0, and here E F G H together, that is C. Okay, so the corresponding value which I need to load, considering that a bit is connected to the LSB and H segment or H or DP is connected to the considered as the MSB. If I change the order, that is H is to the LSB and A to the MSB, then this particular value will be changing. Okay, so here for the time being I am assuming that a digit A segment is at the LSB position and the DP or the H segment is at the MSB position, so that for displaying 0 on a common anode type 7 segment, I need to pass the value through the 8 pins, and that particular value is if I consider, the value should be C0, the hexadecimal value is C0. And for logic 1, only B and C segment should be turned on, all others should be turned off. So corresponding to this, for the first lower 4 bits I have 9, and upper 4 bits I have F. Okay, so I need to load the value F9. So likewise for all the digits from 0 to 9, I have different values which I have formulated. Okay. Similarly, I have calculated the values that has to be loaded to the port, an 8-bit port, where the A segment is connected to the LSB bit, that is 0th bit of the port, and the DP or H segment is connected to the MSB bit. So here, if I need to turn on a particular segment, I need to pass a logic 1. So the opposite of the common anode takes place, and the value is 3F for digit 0, and for 1 the value is 06. Okay. Similarly, for all the values from 0 to 9, I have separate values. Okay. Now if you go for the uh, types, you can see that this is something equivalent. If I just consider the segment A alone, here this is equivalent to, okay, this particular configuration is equivalent to a single LED that is interfaced with 8051 using the low control scheme, and this figure is equivalent to a single LED that is connected to the 8051 or any other microcontrollers in the high control scheme. So similarly, based upon the type of semiconductor that is used, we may be getting a 7 segment display, where on turning on the segment you will be getting a red color, sometimes it may be blue, sometimes it may be white, etc. Okay, you have seen all those things. So based upon the color, again, as we have seen for the LED, we need to use some resistors. Okay, you need to use some resistors in between, so that the segment will be protected from high current or high voltage applications. Okay. Similarly, the voltage limitations, etc., can be done. So that's why by common, in generally we never use a resistors, but it is better to use practice at standard method. So as we had discussed before, uh, LEDs also, here also based upon the color of the segments, okay, color of the color that is emitted by when we are lighting each of the segments, so you can go for resistors design. So the same equation which was used for LED can be also used in this case also. Okay, so it is better to use separate resistors for each of the segments. So here we have the schematic diagram. So as I told, this is a constant side, and here we have the common anode interface, and we have the common cathode interface with the port 3.3, and common anode is interfaced with port 0. Okay, so as we have seen in our previous classes, the features of the various ports, in port 0 it is always better to ensure external pull up. Okay, so I am going for the low control scheme in this particular, that is common anode can be interfaced very easily with port 0, and when we go for common cathode type, it's better to interface with any other port other than port 0. Okay, so individually I am having separate resistors for each of the segments. So rather than using single resistors, discrete resistors, I'm using a pack of 8 resistors. Okay, so that is here you can see we have a pack of 8 resistors, where each of the resistors are having equal values. Okay, so when we go for programming, the same thing has to be done here. So if this is a common cathode, I need to pass that particular value. So we have seen, if I need to turn on 0 in this particular 7 segment, I need to pass the value. For common anode it is C0. Okay, I need to pass the value C0 to the port 0 as per this particular schematic, and for common cathode, if I need to pass 0 to the display 0 in this particular common cathode type 7 segment, I need to pass a value 3F to the port 3. Okay, so we move on to the programming side. So here what I have done is that I have loaded, or I have saved all all the hex values corresponding to each of the digits, that is digit 0 to digit 9. The hex values are now stored in the ROM location. So here from this ROM location I will be fetching each hex code at a time, and I will be passing that particular value to the port, okay, corresponding port. So I have 10 digits, 0 1 2 3 4 5 6 7 8 9. Okay, so total I have 4 plus 4 8, 8 plus 2 10 values for digits from 0 to 9, that is stored in RAM location, ROM location 600H. Okay, so I am initially loading a counter register with R0 as 10. Then I am passing the offset value, this base value of the ROM, to the DPTR. Then I am loading accumulator with 00 value. Then I'm using movc a comma at the rate a plus DPTR, so that the first value from this location, that is C0, is now copied to the accumulator register. Now I'm passing that particular value to the port 0. Okay, and after a small delay I'm incrementing the DPTR and I'm decrementing the count, so that the next bit can be achieved. Okay, so I'm incrementing the DPTR means now the address will be 601H, and the count that I'm reducing, that first digit has been taken. Now to analyze that, I'm going to repeat this process after every 10 bits read. Okay, so I'm decrementing the count and I found that I have not displayed all the 10 digits. So I'm repeating, I'm coming back here, so clearing the accumulator initially, then I'm adding the accumulator value with the incremented value of DPTR, and I'm repeating the process. Okay, so after the 10 values has been read, then I'm going for SHM loop, so that I will be again continuously displaying the value from 0 to 9. Okay, so this program is just an example where I'm just displaying values from digits from 0 to 9 continuously on a common anode 7 segment, which is interfaced with 8051 through the port P0. Okay, so here as we discussed in the case of LED, the delay subroutine is implemented using a symbol uh, instructions. Okay, by using symbol instructions that is supported by 8051 microcontroller. Okay, now if you go for the next program, where this is a program written for displaying digits from 0 to 9 on a common cathode 7 segment display that is interfaced with our 8051. Okay, so as for the figure, we have seen that the common cathode 7 segment display was interfaced with the port 3. Okay, so for that I am using port 3 here, and the corresponding values of a common cathode for displaying 0 to 9 was earlier determined, so I'm loading all those values again in the ROM location. Okay, and here I'm writing the same program. Initially that count register is initialized to 10 count, then the first value of the, or the base address of the ROM, from where I need to get the data, is copied to DPTR. Then I'm initializing accumulator register, copying the first value, that is 3F, and passing that to the accumulator, and after that I'm calling a delay. So here the delay is being implemented using timer. Okay, so that's only the difference. The remaining things are exactly the same for common cathode. Here the only difference is that I am using a common, not common for here I am using common cathode, and the previous case I was using a common anode 7 segment display. Okay, so the need for this is that this is more in this case, in the previous case it was a single LED, so that the turn on and turn off, if you're going for the symbol methodology of implementing the delay subroutine, it may not be a big issue because we can easily identify the turn on and turn off, because there is only a single LED. But here for displaying the digits, multiple LEDs should be turned on and turn off at the given instant of time. So if you are not providing sufficient delay, our eyes may not be able to distinguish between the different digits. Okay, since there are multiple LEDs turn on and turn off at a particular instant. Okay, so it is always better, you can go for implementing the delay between the transition of displaying one digit from the next digit to the next digit, using this uh, timer module based time interval implementation. Okay, it is always recommended for this. Okay, so that's about the interfacing of 7 segment display modules with 8051 microcontroller. So we have seen that there are two different types of segment displays. One is common anode and the one is a common cathode. So common anode means the anode terminal of the LED segments will be connected to a common point, will be connected together, and that single common point should be connected to the VCC. So in this case we can go for programming which is based on a low side control scheme. That is, if I need to turn on a particular segment, I need to pass a logic 0 to that particular segment pin. Okay, and in common cathode, the cathode terminals of all the LEDs of the segments are connected together, and that particular common point should be connected to the ground. So in that particular case, if I need to turn on a particular segment, I need to write a logic 1 to that particular segment pin. Okay, and we have seen that it is better to practice a standard methodology. So based upon the color which is been emitted or emitted in activating these segments, we can go for a resistor interfacing so that the life of the second segment displays can be increased further. Okay, so in the next class we will be discussing about interfacing the other common peripherals or common device external devices like ADC, DAC, stepper motor, etc. with 8051 microcontroller. Thank you.